Chapter 5, which will round out week 3 for us, covers discrete probability distributions. That sounds kind of scary, but hopefully in this section we'll see it's not too bad. Section 5.1 is an introduction to discrete probability distributions. So we have just 2 topics to go over in this clip: the basics of discrete probability distributions, and then a really topic about the significance of the phrase "at least." All right, so let's go back to the basics first. A discrete probability distribution, what is it? As it turns out, it's something we've seen before. It's really the same as a relative frequency distribution. Do you remember that? I'll show you, I'll recap for you in a second where we've seen this before. But basically what it is, a discrete probability distribution lists all possible values for a discrete quantitative random variable and their associated probabilities. Okay, our language is getting kind of dense with tech talk here, so let's make sure we understand all these words. Do you remember what discrete means as opposed to continuous? Continuous is something like a liquid that can flow continuously from empty to full, whereas discrete is something that usually is used to count how many pens am I holding. 1, 2, 3, it could be 4, 5, 6, but that's a whole number. Discrete doesn't always mean whole number, but in our class it almost always does. Quantitative. I hope you remember that quantitative means described with numbers as opposed to qualitative or categorical like red, yellow, and blue. Okay, so once again, a discrete probability distribution lists all the possible values for a discrete quantitative random variable and their associated probabilities. They may be represented respectively as the left and right columns of a table or the horizontal and vertical dimensions on a graph. Last week we saw an example of this when we talked about surveying people and asking them how many children they have. Okay, so in that case, the number of children was our discrete quantitative random variable, and we want to list all the possible values for that variable, which can be, in this example, 0, 1, 2, 3, 4, or 5. And then over here in the right column, we list their associated probabilities. So I'm just being consistent with last week's example. These were the probabilities that we ended up with, or the proportions, as the case may be, represented as decimals. So this is where we can represent the random variable on the left column and the associated probabilities on the right. Or if we graph that, then the random variable x number of children becomes the horizontal axis, and the associated probabilities become vertical probability. Now, one of the important rules of a probability distribution is that it must account for all possibilities. It must account for the entire data set. So in that example, all of the respondents said that they had either 0, 1, 2, 3, 4, or 5 children. So like if we left out this row, the row with 3 children in it, the data would be incomplete. We have to make sure that we include all the possible values over here. And if we do that, then all of their associated probabilities should add up to 1 or 100%. So you'll have a couple of basic homework questions that will give you a table like this, and they will ask you, is this a probability distribution? And all we really need to identify is that all the numbers on this column are legitimate probabilities. In other words, they have to be fractions ranging from 0 to 1, and they have to add up to 1 as a total. So that's a pretty simple thing to check. Okay, a probability distribution has a mean and a standard deviation, just like a list of numbers. Now that's calculated a little bit differently when these numbers are represented as fractions as opposed to whole numbers. So let's take a quick look at how to do that in StatCrunch. And by the way, I hope you remember when you're doing your homework that when you see a problem like this, whenever you have that blue spreadsheet icon, click on that, and you can open it in StatCrunch. So voila, there it is. All right. That actually I was going to use, but I just wanted to remind you where that's located. All right, so here we have our distribution with the numbers of children in StatCrunch. All we've got to do at this point is calculate their mean and standard deviation, because those are questions that will be asked on our homework sets. So I've written the steps on your homework handout. We're going to be going to the Stat menu, and then we'll select Calculators and Custom. It's really hard to memorize these steps, so please just keep your notes and consult them as needed. Okay, so here's the Stat menu. Calculators is the very first choice, and then Custom is the very last choice here. It's going to ask you a couple of questions. Where are the values? The values of the random variable, in this case number of children, are here in the children column. Where are the weights? That's another name for probabilities. So they are in the P of X column. Compute. And StatCrunch gives us this funny looking bar graph, but the numbers of interest to us are down here. The mean is 2.16. So on average, these families have 2.16 children per family, with a standard deviation of 1.3 approximately.